So here's the mechanism for base catalyzed ether formation. We're going to get the same product, but through a different mechanism. So remember, one of the keys to alcohol reactions is that they're not very good leaving groups. They're not very good nucleophiles either. They're neutral and not very reactive in general, but we can do acid-base reactions with them. So to get them to react, we either use a strong acid or in this case a strong base. So this is a two-part reaction. So in step one, the sodium hydride is added. Once that's completely reacted, then the person in the lab would then add the alkyl bromide here. So once this is all finished, then add step two. So it's sort of like two separate reactions in one, but it's just really an order of mixing. Sodium hydride is a non-nucleophilic hydride source. So if you put this in a reaction, it remains a solid. It doesn't dissolve. There's no such thing as free H- in solution then. But it acts like H-, so mechanistically we'll treat it that way, but it can't be nucleophilic in this case. It's just going to do a proton transfer and act as a base for our first step. To give us O-, right? So now we have H2 forms. That's probably going to bubble away as a gas. And then you have a strong nucleophile then to add our alkyl bromide to it. Right, so our first step was proton transfer. Right, really common. Most of the alcohol mechanisms have proton transfer as the first step. And then our second step is going to be an SN2. Right? So we've got a good nucleophile, a good leaving group. These things can come together. Right, I drew the alkyl bromide in red to kind of emphasize where these things are coming from. So two carbons bonded to an oxygen. That oxygen is now bonded to this carbon. Bromine's gone, but there's two carbons there. So it's a little colorful. We have some 3R left over, but it's another way to make an ether. This reaction works a little bit more consistently as long as you're not putting in something that's sensitive to bases here. But that's the overall mechanism to form ethers under base conditions.